Hello, today we are continuing in our A-Level Physics Revision series, this time looking at CT scans. The point about an X-ray image is that it is a two-dimensional image. You simply get on a photographic plate the picture of a bone and maybe some other organs as well, but you've no idea whether a different organ is in front of or behind or by the side of the bone. You simply get the two-dimensional image. What a CT scan, or computed tomography scan, does is it uses X-rays, but in order to produce a three-dimensional picture of what's going on inside. And the way it works is this: it has a X-ray tube, so the X-rays are coming out of the tube here. It has the screen here, and this is all on a big turntable, so that it can spin around. And the screen, where the photographic plate is always opposite the X-ray producer. But on a bed, which doesn't move, is the patient. And so essentially the X-rays are passing through the patient at different angles, and you can build up a picture, or a three-dimensional picture, of what's going on in the patient, him or herself. Now, computers do all the hard work, which is why it's called computed tomography. But basically what it does is it splits up organs in the body into small volumes called voxels. And every organ will have millions of voxels, and each voxel is given a number which represents the extent to which X-rays are attenuated when they pass through it. So, for example, a piece of bone will be broken up into voxels, and each of those voxels will have a very high number, because bone tends to attenuate X-rays. It may not let them through at all, but the intensity of an X-ray having passed through the bone will be very much less than the intensity before it passed through the bone. On the other hand, if the X-rays are passing through a piece of skin, again broken up into voxels, then the voxel number will be low, because it does not hinder the X-ray's penetration. The intensity of the X-ray after it has passed through this kind of material will be as high as it was, or almost as high as it was, before it went through. Now, although the body is divided up into many voxels, to give you an idea of the principle of the thing, we are just going to consider 4. Here are 4 voxels, and I'm going to tell you, but we don't actually know that this is true, that's what we're going to find, but as it happens, the values of each voxel are 3, 4, 1 and 8. So these are parts of the body that have different transmission rates for the X-rays. 8 means that the intensity of an X-ray passing through this particular bit of the body will be significantly attenuated, significantly reduced. Whereas 1 marked 1 means the X-ray attenuation will be very small. You will not reduce the intensity very much indeed. And what we do is we pass X-rays at 4 angles. We're going to go that way, we're going to go this way, we're going to go this way, and finally we're going to go this way. So 4 angles. We're going to look at it that way, this way, and this way. And what will we get? Remember, we don't actually know that it's 3, 4, 1, 8. I've simply told you that. What we want the computer to do is to work that out. Well, what will happen when we go through in this direction? So the X-rays are travelling through and onto a screen here. Well, that will measure that the total attenuation of the X-ray passing through this section here, the total attenuation will be 7. And the total attenuation coming through this section will be 9. We don't know how the two are made up, but we do know what the total attenuation is. What happens now when we move the X-ray round 45 degrees so that it's now coming through this way? Well, the X-ray that comes through this part here will come down as a 4. The X-ray that comes through this part here will come down as an 11, and the X-ray that comes through this part here will come down as a 1. Now we turn the X-ray round, the machine round another 45 degrees, and now we've got X-rays coming from the top onto a plate at the bottom. What will we see there? Well, 3 plus 1 is 4, 4 plus 8 is 12. So the total attenuation, the total reduction in intensity of an X-ray coming through that on that line will be 12. The reduction in intensity here will be 4. And finally we come through this way. The X-rays are coming through this way. The X-rays coming through here will come as a 3. The X-rays coming through here will come 4 plus 1 is 5. And the X-ray coming through here is 8. And so we've got 4 different descriptions. The X-rays coming in this way give you a 7 and a 9. The X-rays coming that way give you a 4, 11 and 1. The X-rays coming this way give you a 4 and 12. And the X-rays this way give you a 3, a 5 and an 8. And what the computer then does is it applies an algorithm or a formula for working out what the individual constituent parts of the voxels of this 2x2 array, of course it's going to be much bigger than that, but we're just doing it simply is. And the way you do it is you take firstly this result and you construct a 4x4 which has 7, 7, 9, 9. Then you take this result, the 4, 11, 1, and you feed that through in the direction that the X-ray is travelled. So you get a new grid. 4 plus 7 is 11. 11 coming through both of these. 11 plus 7 is 18. 11 plus 9 is 20. And finally the 1 comes through the 9. So 1 plus 9 is 10. And this is what the computer is doing. Now we add to that the consequence of the X-rays coming in this direction, which gave a 4 and a 12. A 4 and a 12. So we add that to the values of each of the boxes. So effectively you're adding 4 to 18 to make 22, 4 to 10 to make 14, 12 to 11 to make 23, and 12 to 20 to make 32. And then finally we take the effect of the X-rays in this direction, which gave us a 3, a 5 and an 8 coming in this direction. And so what we do is we create now the final grid. We add 3 to 22, that becomes 25. We add 5 to each of these two, so 5 plus 23 is 28. 5 plus 14 is 19. 8 plus 32 is 40. Bear with us, we are almost there. The next part of the algorithm, this is what the computer is doing, is it takes the initial combined total, which is 7 plus 9 is 16, and you subtract 16 from each of these boxes. So if you subtract 16 from each of these boxes, 25 minus 16 is 9, 28 minus 16 is 12, 19 minus 16 is 3, and 40 minus 16 is 24. So we simply subtracted the value of the combined total of the initial X-ray scan, which gave us a result of 7 and 9 as it came through these two parts. And then finally, because you have done not just the initial scan, but 3 more, so you've got essentially 3 lots of weighting, you have to divide what you're left with by 3. So if we divide 9 by 3 you get 3, 12 by 3 you get 4, 3 by 3 is 1, 24 by 3 is 8. And you'll notice that what we've ended up with by our computer or computed tomography is a set of voxels which is the same as what we started with. But I told you we didn't know what that was. That's what we needed to find out by sending X-rays through in 4 different positions, adding up the values, subtracting the 16, dividing by 3, and that gets you the answer. Obviously, when computers do it, they have to do it for a whole range of voxels, which is why it's quite complicated. It's also why it's very expensive. But that's what gets you your 3-dimensional pattern of everything that's going on, so that your whole body is divided into voxels, each with a number, which represents the, as it were, the absorption or the attenuation of X-rays as it passes through that particular bit. And so you're able to construct whether there's a bone here, or maybe there's something that shouldn't be there, whether there's skin there, whether there's water there, whatever it may be. The CT scan can construct it and make it look like a 3D image. But of course, one very important point to notice is that the patient is receiving a lot more X-rays this way than they would from a standard X-ray machine, which simply produces one 2-dimensional pattern. Here, the patient will have to sit on the bed whilst the X-ray machine is put in the position that way, then that way, then that way, then that way. So 4 lots of X-rays, and then all of that information is sent off to the computer, which essentially does this kind of calculation in order to find out what the individual voxel elements are for the material in the body through which the X-rays have passed.